Hello and welcome everyone to our webinar on the introduction to Amazon Sidewalk. This webinar is a partner webinar between Nordic and Amazon Sidewalk. Today's speakers, the first one, this is me, Finn Boetius, Product Marketing Engineer here at Nordic Semiconductor. You might notice my voice is a bit different today. That's because I've been a little bit sick, but it's still me. With me I have Krzysztof Loska, who's the Technical Product Manager. And he's also responsible for Amazon Sidewalk on the Nordic side. So he will be able to answer all the difficult questions. And then from the Amazon side, we have Ben Cook, a Senior Partner Solutions Architect at IoT, so at IoT AWS, so at Amazon Web Services. And then we have Roberto Sondre as the Lead Product Manager for Amazon Sidewalk. We're gonna start this off. Very briefly with a quick introduction from my side, from the Nordic side, and most of the webinar today is gonna be an introduction from Ben and Roberto. So very briefly, Sidewalk can be split up, or you can divide it in basically two parts. One of them is a pure Sidewalk over Bluetooth LE part. And we will get a lot deeper into this in the Amazon session. But you can basically think of it as a connection from a Bluetooth LE device directly to the cloud on the end device side. And this connection is highly focused on data privacy and security. And then another side of Amazon Sidewalk is Sidewalk over Sub-GHz. You might know that Nordic isn't doing sub-gigahertz transceivers, which is why you see a third name in here, which is Semtech. So Sidewalk over sub-gigahertz is a longer range Sidewalk variant. It's using 400 megahertz ISM band as a transport. And in the Nordic solution, this is, as I mentioned, provided by Semtech. But there's still a Nordic SoC that hosts the application, so is the application processor, and is providing the Bluetooth LE connectivity. Okay, which hardware can you use from Nordic? We started Amazon Sidewalk off with the 52840. I'm guessing most of you are familiar, but very brief overview again. It's one of our multi-protocol SoCs, runs a Cortex M4 with a floating point unit, 1 megabyte of flash, 256 kilobytes of RAM, has a high output power for 8 dBm, has a bit of crypto, has 48 GPIO pins, and has a temperature range up to 85 degrees Celsius. This is the development kit for it. As you're used from our development kit, it has user programmable LEDs and buttons. It has the Arduino headers. It has the onboard Sega J-Link programmer and debugger. And it has multiple power supply configurations. We relatively recently also added support for the NRF5340 SoC. This one has two Cortex M33 processors. It has a bit more processing power. It is more energy efficient. And you can get the PSA level 2 with this one. So you have better security options if that's something you need. You also can get up to a higher temperature range. And the development kit is very similar to the 52840 in that it has access to everything you need. It has the buttons, has LEDs, and has Arduino headers. These will also become important very soon, because if you want to use LoRa, or if you want to use the sub-gigahertz, you need to add a development kit from Semtech to it. From Semtech, usually we use the SX1262 transceiver, which is a modem for LoRa and FSK. And this one is natively supported in NF Connect SDK. And this is also what we're using in our Amazon Sidewalk samples. There is also another Semtech IC that can be very interesting. Well, they have several of them, but these two are specifically interesting for Amazon Sidewalk, which is the LR11 series of transceivers. And these have, are also a LoRa and FSK modem, but they also support Wi-Fi and GNSS scanning and ranging. And they have compatible drivers that are distributed separately from NF Connect SDK and are available on the Semtech GitHub. For our Amazon Sidewalk solution, we, like in our NF Connect SDK, as I mentioned before, we're using this transceiver, and it has a very well-fitting development board or evaluation board that you can just add to the Arduino header. So basically just stack it on top of the NF 52840 DK or 5340 DK, and it's natively supported in NF Connect SDK. Keep in mind, if you're working with sub-GHz frequencies, these are not the same the world over. So this one is for the region of North America, and the frequency band is 915 megahertz. And I'm guessing this is not too much of a hindrance, since at the moment Amazon Sidewalk is only available in the US. When it comes to support for developers, most of you should be used to this. We have our NF Connect SDK that has lots of support. But when it, like specifically for Amazon Sidewalk, we have user guides in how to set up the Sidewalk environment, how to register a Sidewalk endpoint. We have the samples for Amazon Sidewalks, sample applications for Amazon Sidewalk, and then enterprise toolchain and IDE, kconfig, device tree, everything you're used to having. Yeah, the same is true for our mobile applications that can be very useful here, and our support for DevZone. And one very important thing, Nordic's Sidewalk solution has been qualified through the Works with Amazon Sidewalk program. So you know it works. Well, it should also indicate that we're doing a joint webinar, but yes. And then Sidewalk integrated into NF Connect SDK. In a previous version, we had Amazon Sidewalk in an external GitHub repository. That is not the case anymore. As version 2.5.0, Amazon Sidewalk is natively connected to NF Connect SDK. It does not automatically come with it, or is not always distributed, which is a licensing issue. So the only thing you need to do is go through one extra step that has you accepting the license, and then you can use Amazon Sidewalk with NF Connect SDK. So there's no, it's just a licensing issue, because in NF Connect SDK we are using an Apache license, which is not the same as the license Amazon is using. Okay, and with that, I'm only gonna talk about one more slide, the Sidewalk samples and applications. Here, the one I want to highlight is the sensor monitoring sample, which can be used via Bluetooth or sub-GHz, and is an application, or like is a sample application that can be used for a sensor application. So you can send sensor signals directly via Bluetooth or sub-GHz through an Amazon Sidewalk gateway to an AWS cloud. And in our case, we use temperature, but obviously you can do what you want. And the application server and cloud backend with Web UI are compatible with the sample that's provided by Amazon. Okay, and with that, I'm gonna hand it over and let our colleagues from Amazon take it from here.
Thanks to the Nordic guys for inviting myself and Ben to talk about Sidewalk. I'm Roberto. I'm leading product management for Amazon Sidewalk, as Finn already said. So I'll give you a brief introduction to what Sidewalk is, why we built it this way, what type of challenges it addresses, and some of the key applications where we see traction from the market. But before I start, I wanted to stroll down memory lane and go back to the second millennium, to 1999. And go back to when the term IoT was coined for the first time, and give credit to a fellow Englishman called Kevin Ashton, who at that time was pitching to P&G an idea around a solution to solve the problem of out of stock for brown lipsticks. And Kevin had this idea of attaching a UHF RFID sticker to the brown lipstick and connect that sticker to the cloud, and inventing the term Internet of Things back in 1999, so more than 20 years ago. So Kevin conceptualized a world where essentially when things are connected and they sense data and they provide their identity, this can give a lot of value for businesses, consumer, and communities. And So he pushed on this idea of things where things are small t things connected to the internet, where all the data flow from things to cloud. And if we go back and we future go forward in the future 20 years later, this definition of IoT has expanded from things to devices. There are many devices that today are connected to the internet, but things are actually not have not expanded to the concept that Kevin originally portrayed. Let's look at some of the basic examples of IoT applications. We can we want to know where the things that we love are, and we also want to know why isn't the city able to pick up the trash and all the trash can overflow. And I also wanted to bring up a use case that has a significant magnitude in terms of total available savings that can be realized with IoT, with an IoT solution. So one of 60 households in the U.S. suffered every year from water and freeze damages. So this represents a total of 20 billion of payouts that insurance have to make every year to cover the water damages. Each water and freeze damage claim is about $11,000. So this gives you a view of the significance of some of the solutions that today could be addressed with the IoT type of applications. So let's go back again 20 years ago. In 20 years, so there is a plethora of wireless connectivity technologies that have been developed that address low power devices, that address roaming devices, and that help connect devices to the internet. But what is really missing is the idea that there is no actual solution to problems that are pretty typical, like water damages that occur every year. So why is that? So what are some of the challenges that hinder the development of solutions that use IoT technologies? So first of all, there is a lot of user friction. People have to, in many cases, when they connect their devices to the cloud, they have to download an app, they have to install it, they have to provision devices. When they connect their device to a Wi-Fi network, they have to insert password. When they change their SSID, they have to update the passwords, and users do not want to consumers do not want to become IT managers of their home. So this an interesting fact that I report here is that when we surveyed appliance manufacturers, we realized that there is a huge problem with the wireless connectivity for the appliances, and they quoted that more than 50% of the appliances that have connectivity like Bluetooth and Wi-Fi are actually not connected to the cloud. The second issue is the establishment of connectivity in areas of the home and just outside of the home that requires a longer range connectivity to either the home router or that requires the purchase of a range extender, which is an extraneous device in the network in the home that users have to install and maintain. And then the third item, as I said before, is the challenge of establishing and maintaining a continuous link to the cloud. Back to the example of the water freeze sensor. The idea that a water and freeze sensor can continuously sense and push data to the cloud, where you have an infinite amount of storage and compute and analytics that can be leveraged to develop a solution that can identify when a problem has occurred, is fundamental to solve the actual problem of identifying when the water damage occurs. But today, all this cloud compute and storage is underutilized because, as I said before, devices don't normally come with native cloud connectivity. So now that we explained the problem, I wanted to get more into the details of what Sidewalk is and the way we built it, underlying some of the characteristics of the Amazon Sidewalk network and technology. So what is it? It is actually both a network and a technology. So we built this network to be public and open to developers that want to develop their own sensing application and connect those sensors to the cloud. It's a crowdsourced network, so it utilizes the millions of Echo and Ring devices that consumers own, and those devices are used as a bridge to the network. So the network is crowdsourced, and it, again, leverages the existing of those devices to send the data to the cloud. We launched this network initially back in 2019, and in March this year, we opened it up to developers to develop their own applications. And the network today covers more than 90% of the US population. The network is launched only in the US for the moment. And as I said before, it's not just a network, but it's also a technology. So we made available a set of developer assets like HDKs in partnership with silicon vendors like Nordic, SDKs, documentation, tools like coverage maps and test coverage kits, as well as example applications that developers can leverage to kickstart their development. So again, going back to the architecture and the fundamental attributes of the technology, there are three major components of the Sidewalk technology. So there are the endpoints. Those are like the mailbox sensors and trackers devices and path door light devices that are installed in the house or at the periphery of the house, or that are roaming in the network. Those are typically battery-powered devices, so they send pings and sensing data to the network. The data is actually bridged by the tens of millions of Echo and Ring devices that consumers own. Those devices, they are actually products that perform a main purpose, like they're either speakers or doorbells, and they have a secondary function of being a relay of data for those endpoints to the cloud. And the devices are natively connected to AWS IoT Core, which provides essentially an entry point to the cornucopia of application services going from analytics to machine learning to storage and compute that AWS offers, thus simplifying the development of the applications. So Finn talked about it just earlier. There are three main connectivity links that Sidewalk supports. Sidewalk is a dual band connectivity protocol. So it supports 2.4 gigahertz radio with Bluetooth LE, and it also supports longer range sub-1 gigahertz radio with two modulation, which are frequency shift keying and chirp spread spectrum, or more notably known as LoRa. So why three, and what are the functions of those three? So for, let's say, in-home traffic and bursty traffic application, sensors can leverage on Bluetooth LE. For applications that instead either require longer range communication because the products are installed in the backyard or at the periphery of the house, or in dark homes, or in dark areas like the basement, or devices are roaming around the network, then a sensor would choose a sub-1 gigahertz communication link, which provides longer range. And the difference between FSK or frequency shift keying and CSS or LoRa is the bit rate and range capability. So essentially, developers can trade off range, power consumption, and bit rate by selecting between FSK and LoRa for slow frequency rate of applications with LoRa, and higher throughput application with FSK when range is at need. So I talked about it before when I mentioned that Sidewalk is a crowdsourced network. And so privacy and security are not just fundamental to the technology, but are also existentials. So we built the technology with several security foundational elements in mind. So there are 3 layers of encryption and authentication for each Sidewalk packet, and identity of the devices and the bridges in the network are constantly rotated. This is to ensure that the bridge owners and even Sidewalk are not able to see who is the owner of the endpoint or the end devices that are sending data to the network. Conversely, the owner of the endpoints cannot know which bridges the data has been going through when transitioning onto the Sidewalk network. Ultimately, as well, we give control to the user to choose whether or not to participate onto Sidewalk, opt in or out of Sidewalk when they set up their Ring or Echo device. So essentially, there are several benefits and values that Sidewalk provides to applications. I already delved into some of them in the previous slides, like being cloud native and having a secure connection to the cloud, and the ability to provide a longer range communication, and so the ability to support beyond the fence type of use cases as well as on the go use case. Here in this slide, what I want to talk about is also the ability to work without the need of an app or a phone, or also without the need of having a commissioning or a provisioning required to connect to the network. So we developed Sidewalk natively incorporating a feature called frustration-free network, which essentially allows a device from the birth, the moment that is powered on, to safely and securely connect to the network. We do that by the use of certificates that the Amazon Sidewalk team vends to the product. And so those certificates are installed in the device at birth. And so the Sidewalk devices use those certificates to securely connect and authenticate to the Sidewalk network the moment that they are powered on. An overview of some of the use cases where we see the biggest traction for since we launched the network and the technology to developers back in March 2023. So obviously, one big application segment is location trackers because of the roaming capability of the network. Another segment where we have seen a lot of traction, especially for devices that are installed outside of the home, like solar panel monitors and air quality detectors, come from these environmental sensors that require longer range. But we also have seen the market interest in applications like appliances that, as I mentioned before, have challenges to be connected to the network and need to continuously send telemetry data to the cloud and leverage on the cloud for applications like logging or predictive maintenance. So I hope I was able to convey some of the biggest attributes and traits of the Sidewalk technology and the main application segments that it applies for. And I want to pass it over to Ben, who is going to focus more on how to get started and how to connect Bluetooth Low Energy devices to the cloud.
Yeah, hey, thanks, Roberto, and hi all in internet land. So I'm really excited to be here today to talk to you a bit about Amazon Sidewalk and AWS IoT, and really specifically how this is going to help connect BLE devices to the cloud and really help usher in a new generation of connected low power devices. But I want to just start off with kind of a quick intro to AWS IoT Core. So AWS makes it very easy to connect virtually any device to the cloud, whether it's powered by a microcontroller or microprocessor. IoT Core really forms the backbone of IoT deployments. It's the central hub or service in which customers can take advantage of connecting devices that exist outside of the cloud. And the thing is again, it exists in the cloud, which means it's you typically need an IP connection to connect to it. And traditionally that would be, say, MQTT. Use the IoT Core MQTT broker, or maybe an HTTP endpoint. Now, when we look at a traditional BLE connected device scenario, well, BLE devices are not IP devices, and so you need a hub or a gateway to connect to these two. If only to do the protocol translation. And when you look at this system as a whole, a lot of challenges will arise. I mean, say you're focused on, building a low power BLE sensor for maybe a medical application. Like, well, I just need to get this data to the cloud. So a traditional approach, of course, is to use a mobile device, or again, use a hub gateway, create your own bespoke protocol translation, manage the onboarding and security of the gateway to the cloud endpoint, and onboarding of end devices. And at the end of the day, this really generates a very large engineering effort to put together this full system. And I've struggled in the trenches with a number of customers, I'll say, in assembling such a system in kind of this bespoke protocol translation manner. And because of that, you will see there are a lot of decisions to be made. There's a lot of challenges, especially, even looking at the hub and gateway side, to support a device that is going to be mobile, that's going to move around in the world. There are multiple gateways that are going to be needed, maybe a fixed headless large gateway, a small mobile one. You've still got Android, iOS apps to contend with as well. And then again, managing kind of the security and onboarding of all of these. And so again, it's a non-trivial effort really to put together this full system. But this is really why I'm so excited for what Amazon Sidewalk and AWS IoT Core bring to the table here for BLE devices, is that with Sidewalk and really IoT Core for Amazon Sidewalk, or integration to the network, the kind of undifferentiated heavy lift of the gateway and protocol translation is really managed for you, is handled for you. And it enables devices to roam by default. So, I've seen some questions pop up in the chat. This is not just a beaconing kind of technology. Devices do beacon for a connection. They have to get an active connection from a gateway before they can actually send a message. But the neat thing about this is that the device is gateway agnostic. The device can start beaconing, and then any bridge within range will make that connection and offload the data. The device can go back to sleep, or it can maintain the connection if it likes. And because of that, again, it really simplifies this BLE to cloud type of connectivity. You really just worry about what you put into the payload message in the stack of your device, establish the connection, and then the payload shows up at a destination in an IoT Core. And one thing I want to make note of here is that IoT Core, in encompassing all these different device types, makes it easy to manage, again, IP devices and non-IP devices like this. But most importantly is the provisioning and identity of the devices. And you probably saw earlier in Roberto's slides the kind of layers of security that are used to build this technology. And one of those, of course, here is what really ties that last bit of encryption that ties device to your specific AWS account and IoT Core instance. And that's all something you manage through this integration for IoT Core for Amazon Sidewalk. Now, I want to talk a little bit about the cloud integration points. Again, it's non-IP, so what does it look like in IoT Core for how do you control the message routing, and then how do you enable kind of bidirectional communication to these devices? And it's done in a couple of key points. One is this concept of a destination, which is really kind of the routing specification for a device or group of devices. And with that destination, you simply point it to an IoT rule or an MQTT topic where it will publish to a topic on the broker. And that provides the means to know where all your uplink messages are going to land in your account. Now, downstream, there is there are APIs or IoT Core wireless APIs that are used to send messages downstream to devices. And technically, this goes from IoT Core through the integration to the network, and then out to the device through the bridge. So there's kind of the upstream and downstream side of this system, but from a cloud perspective, we provide this sample application that Finn alluded to earlier in the presentation, which is a modern cloud architecture, serverless design that leverages Lambda functions and DynamoDB table for storage. But at the end of the day, what this produces is this little application you see here on the right-hand side of the screen, this sample application. And we released this to show, really what's possible, really to help developers get started with this technology. It lets you control the LEDs on the Nordic DK boards. You can see button presses. You can see the temperature data come in. But it really is there to, again, give you a good head start to using this technology. And it is also very easy to deploy. And so, with most things in the cloud, unfortunately, we can't cut and paste a million devices into existence. But fortunately, in the cloud, we have a lot of flexibility for automation and being able to deploy this application and infrastructure very rapidly through technologies like CloudFormation or CDK. And that's all rolled up in this sample application. And so, in a very short period of time, you can deploy this into a free tier account and be able to get a light blinking quickly. Now, Finn also alluded to this as well, but I wanted to help connect the dots a little bit between the two. From the device side, the Nordic team releases the Sidewalk SDK and some examples, but specifically the sensor monitoring example is what pairs with the bit of cloud architecture that I showed you in the previous slide and in this application. A couple of the other templates here also show you how to get started and just kind of a bare bones approach to things, but you still have to worry about how you're going to decode your payloads in the cloud and things like that. Whereas the sensor monitoring application is really an end-to-end system, both device side and cloud side software in order to see this whole system work. Now, from a capabilities perspective, I wanted to talk a little bit about this. And this is one of the really cool things about the Sidewalk stack in general is being able to manage kind of multiple radios from a single stack. And that, BLE out of the box, it is a requirement for Sidewalk devices. It does have the shortest range, but it has the highest data rate and the highest MTU, highest payload size that you can send for a given message. Moving into kind of the mid-range and long range, we have mid-range, which is FSK, provides quite a bit more range, but it has a significantly lower bit rate for messages up to the gateways or the bridges, slightly smaller MTU size. And then we get to LoRa, and note this is not LoRaWAN, this is LoRa, just the CSS modulation technique. Of course, you get to a significantly further range, but again, much lower data rates, much lower payload sizes here. So, as a low power kind of background network, if you will, you're not going to be streaming video over this technology by any means. But, if you look at, say, Wi-Fi for a light bulb, is that overkill to put a mini megabit or gigabit type of radio technology for something that might need just simple on-off commands or state? And this is something where Sidewalk, for the right fit and the right use cases, can be a really compelling technology. Being able to build provision devices that will come up and work and connect wherever they are in the field, not requiring a mobile application in order to get the cloud connectivity, not requiring a user to open up that application in order to get the connection, is again, a very compelling reason. And to Roberto's point earlier, again, Wi-Fi connected devices, yes, there are lots of commissioning techniques for those, to join them to the networks, but some consumers just won't do it. And so it can be a challenge, whereas Sidewalk does present an opportunity to build connected devices that will be cloud connected wherever wherever they may roam. So with that, I wanted to just kind of summarize some of the tools available for development. So, of course, our friends at Nordic have a very nice landing page that will walk you through how to use and set things up with NRF Connect. On GitHub, there are a number of examples as well, including the IoT sample app to help you kind of get started on the cloud side. The Sidewalk team has also released a coverage test kit, which is this little tracker device that you see there on the bottom, on the far right-hand side of the screen, that will give you your own, if you request a test kit, it will give you your own little portal or window into location, and it is very helpful in determining, do we get Sidewalk coverage? I'll say specifically for the LoRa or CSS radio, wherever you may take it. So you can get some live data on coverage of the network. Now, I wanted to, this is a fairly brief webinar, but I wanted to leave you with a few places to kind of get started. So, definitely go take a look at the Amazon Sidewalk coverage. It is, of course, US only based currently. But then also, take a look at the NRF Connect SDK. Nordic's done an incredible job at kind of packaging up the developer experience there for using the Sidewalk stack within NRF Connect. And then I also want to link you to the Amazon Sidewalk documentation. This has the full specification for Amazon Sidewalk. It has a full list of the gateways, the Echo and Ring products, and what radio technologies they support. I will be upfront that not every gateway supports every radio technology, and so it's one of the, I think, primary questions that we get asked. But it's right up there in the Amazon Sidewalk documentation site. On the cloud side, there is also a good amount of documentation around IoT Core and using it from the cloud perspective. And then again, check out GitHub for the reference application. And then lastly, there's a link here to request a test kit if you'd like to explore the technology a little bit further. So, with that, I think that's the end of my session and in our brief presentation here. I think we're going to open it up to Q&A.
Good. Okay. So what are the rollout plans for Amazon Sidewalk outside the US? I think that's a question for Roberto.
Yeah, so I see this as a frequently asked question and recurring. Look, we cannot share publicly roadmap information about Sidewalk deployment outside of the US. But what I can say is this: the radios that are incorporated in Echo and Ring devices are both capable of doing, I think the problem is mostly for sub-1 gigahertz. They are capable of doing 868 and 900 megahertz. So there is already hardware forward compatibility towards expansion in the outside of the United States. And definitely, since we launched, we got a lot of market traction. So it's something that obviously we are looking into very, very scrupulously. we want to first make sure that we have success in the US, and based on the traction that we get from customers for deployments outside of Europe, we will accelerate in the next quarters the deployment onto Europe. We are here to listen to as well some of the market feedback. And we get this question all the time.
Yeah, we actually have like 3 questions that are basically this, so I'll skip the other 2. The next one would be, what should be done for side? Oh no, that's okay. 4 questions that are the same. Then the next question would be, are Echo devices Sidewalk gateways? I guess we could expand this to, are all Echo devices Sidewalk gateways, or which Echo devices are Sidewalk gateways?
Yeah, so I think somebody has pasted the link in the Amazon doc that lists all the Sidewalk capable gateways and which PHYs they support. So not all of the Ring and Echo devices are Sidewalk gateways, but most of them are. And you will also see that many of the Echo devices, even the low-cost ones, support at least the Bluetooth version of it. And there are several of Echo and Ring cameras, doorbells and floodlight and spotlight that support, there are dual band that supports the 2 PHYs, the 3 PHYs.
Roberto, I can just paste it in the chat for everybody's benefit here. Here is a link to the listing of all of the Sidewalk gateways.
Yeah, and just so you know, even we are continuously updating the list. A few products were launched this year, and then more products will be launched beginning of next year and throughout 2024 that will continue to support these Sidewalk PHYs.
Okay, then this one is probably for Christoph, I think. So can I do Amazon Sidewalk development on my Thingy 53?
So what we natively support in NRF Connect SDK version 2.5 is DKs for NRF 52840 and NRF 5340. But we also provide device tree definitions for Thingy within the SDK. So I believe you should be able to quite easily transform the existing sample for 5340 DK into the Thingy.
Okay. Good. Then let me check what else we have. This one is probably also for you, Christoph. What is the hardware recommendation for Sidewalk? Like, what's the minimal recommended Nordic chip? I mean, we kind of answered it at the beginning, but maybe you can go into it again.
Yeah, I can explain a bit more. So the minimal, what we recommend is NRF 52840. And this is because the baseline application for Sidewalk over Bluetooth LE, it takes around 380K of flash and around 75K of RAM. So NRF 52840 is a perfect solution because you also would like to probably have a capability of device firmware upgrade. Then having 380K for the baseline application gives you like around 120K for your unique code, and then the other 500K is a second bank for device firmware upgrade. When you use Sidewalk over LoRa or FSK, the baseline application is around 500K, which means that you need an external flash memory to store a new DFU image.
Okay, thank you. Then I think this one for Roberto again. Is Sidewalk compatible with Bluetooth LE TX only beacons?
Not today. We require bidirectional communication for Sidewalk devices. I mean, that's because of the privacy and security. So we need to handshake and exchange identity and security material. So today we cannot support TX only advertiser only devices.
Okay. And can you speak a bit about the commercial adoption? Sorry.
Yeah. So when we launched the network in back in March, we also there were also a couple of products that were released. Some of them are sold. When I say product, I mean end devices. Some of them are sold on Amazon.com. So there's a door and window sensor, an air quality monitor, a water leak detector. And a PIR sensor, a solar panel monitor. There are a few other products upcoming, but I also want to note to the public here that the ring cameras, the floodlight, the spotlight cameras today also. In addition to acting as a, let's say, bridge to the cloud, they have an endpoint mode where essentially they are able to relay the motion notifications the camera captures, and they are able to relay this motion notification functioning as an endpoint to the Sidewalk network. So in case that camera loses the Wi-Fi connection and so is not able to send the motion notification directly through their Wi-Fi network to the cloud, they would use the Sidewalk network. So they will use a neighbor device to hop on and send that motion notification. So those cameras essentially act as Sidewalk endpoint when they are in stress mode and they lose their Wi-Fi connection or their internet connection. And there are several millions of them that already function this way, so that motion notifications are not lost when the home internet goes down or the Wi-Fi goes down.
Okay. Then this one is probably one for Ben, I think. If there's no provisioning required to connect or validate the device with the cloud, is there any other process to connect with AWS IoT?
I think I understand this one, and this is one that I need to probably go into a little more detail on regarding provisioning. You absolutely have to provision devices. This is a certificate-based identity on the device in order to connect to the network, kind of bootstrap into its maybe session keys, if you will. That process starts at IoT Core with the definition of a profile, which is kind of provides the, let's say, cryptographic underpinning of the device identities, wireless devices that fall underneath that. And within Sidewalk is a little different from a maybe go-to-market perspective in that in order to produce production devices, they must be qualified by Sidewalk, by the Sidewalk team, and Gain works with Sidewalk. The output of the qualification is an HSM that enables the provisioning of identity, establishment of identity for wireless devices. But we've been very generous, I'd say, in that each profile that you create with an IoT Core, you can generate up to 1,000 prototype identities. And so again, it starts at IoT Core in the creation of the key material, if you will, the underpinning, and then the registration to the network for those devices. You then, that material is taken and provisioned into your end devices. And when they connect in the field, that's where they're onboarded and then, effectively bound to your AWS account. So I don't know if that's maybe too much detail, but again, provisioning is absolutely necessary. It starts in IoT Core. you can provision prototype devices that way. If you go beyond prototype devices, I would, you definitely need to check out the qualification process, to qualify a device profile and move into a manufacturing stage.
Okay, thank you. I'm looking at the time, so we have a lot more questions than we will be able to answer. Maybe one just came in that I think might be interesting to ask, like, what's the pricing? Like, how much does one need to pay to send messages over Sidewalk?
I can.
Oh, you want to take that one? Yeah, no, go ahead. Go ahead.
Yeah, I can. You'll see it's priced very much like LoRaWAN, if you will, in that I think it's around $2.30 US per million messages that traverse that interface.
Okay. And that's a very good answer. Maybe because I'm just cherry picking because we probably have one more question we can do. Is there any support for Matter over Thread with the Sidewalk architecture?
Not today. As I said, from a wireless connectivity standpoint, we support those 3 PHYs that I mentioned, and Matter is an application layer protocol. So essentially, somebody could build a Matter plugin on top of the Sidewalk application. On top of the Sidewalk networking layer. So Sidewalk is a networking pipe. So it doesn't preclude the support of Matter.
Okay, and then I think for the last one, does Matter support Bluetooth 5.1 plus?
The Sidewalk support Bluetooth 5.1 plus. So today we support the construct of the minimum requirement from a Bluetooth standpoint is 4.2. So we only support the Bluetooth LE 1 megabit per second PHY. 5.1. I don't recall if it was 5.0 or 5.1 that they introduced in the new PHYs. I think it was 5.0. So we don't. Yeah, it was. You guys are better expert than me on this. So we don't support the coded PHYs, and 5.1 plus are all the advancement on periodic advertising and so forth. So we don't use those construct of the link layer in the Sidewalk protocol.
Okay. Then we are actually out of time for this webinar. So I want to thank you all for joining here. I want to thank our guests for presenting. Yeah, and with that, thank you all for joining, and see you in the next webinar.
Excellent.
Thank you.
Thank you all.